Hey guys, welcome to the start of Chapter 5, which is also the start of Unit 3, our last unit. So just so you guys know, this unit is all about linear relations. We have Chapter 5, 6, and 7. Each one is going to have its own quiz. So we're starting with Chapter 5, and this lesson is all about the different way that we represent relations between things. So 5.1, representing relations. And we'll start, I spelled the word relation wrong already. We'll start with just a definition of what a relation is. So a relationship is anything that shows the relationship between two sets of terms. And those two sets of terms could be two sets of numbers or two sets of words or one set of words and one set of numbers. And there are 4 different ways of representing relations that we're going to be looking at today. The first type is a table. So these are 2 different examples of a table that represents a relation. The first example has a relationship between words and numbers. So here I've got the province and the population of each province. So we would just read this as like Alberta has 4 million people, and BC has 4.6, and Ontario has 13.4, that sort of thing. Or you might have a table where both sets of terms are numbers, and we see this often as like XY tables like this, where you might have that the X value of -2 will have a Y value of 8, for instance. The second way of representing relations, which is probably the least common way, is something called an arrow diagram. So you have 2 kind of ovals here that show your sets of terms. If you have sets of terms that are words, sometimes they might be alphabetical, sometimes they might just be in a random order. Sets of numbers should be from least to greatest. And then at the top, it's showing what this is a relationship between. So these are provinces. It's saying that the province has a population of, and then the actual population size is in the second set. And then we just draw arrows connecting the terms in set 1 to the corresponding terms in set 2. And they don't have to go straight across, they can kind of go any which way. The third method of representing relations is a graph. In the first example here, I have like a fully developed graph where I've got a title, I've labeled both my axes, and then I'm comparing again one term, which is words, and another term, which is numbers. This is the population of the provinces again. I can also, of course, have a graph where on both axes I have sets of terms, which are numbers. And in that case, you do have to make sure that on your x-axis, which is the horizontal one, you have your independent terms. And on your y-axis, which is the vertical one, you have your dependent terms. And we'll talk about what that means in a moment. The last way of representing different relations is using an ordered pair. So an ordered pair is just a bracket that contains the 2 related terms. So again, it could be 2 numbers. So I've taken this first ordered pair, 2, 5, right off of this graph. Whenever you're writing an ordered pair, it does have to be in the order of X and then Y. So if you're reading it off of graph, you read the Y-axis first, sorry, the X-axis first, and then the Y-axis. And I did that for this second point as well. Reading this point here, I go down to the X-axis first and read the 4, and then over to the Y-axis and read the 10. And you can also do this even if one of your sets isn't numbers. So for example, if I was doing the provinces, I might read this point and say, okay, it's Alberta, and then over to the y-axis is 4. Or Ontario, and then over to the y-axis is 13. So when you're doing the ordered pair, again, it does have to be XY. Another way of saying that is that it has to be the independent variable and then the dependent variable. Because as I said when I was doing the graph, the independent variable has to be on your x-axis, so your x has to be independent, and your y-axis, or your y variable, must be dependent. So the last thing we'll talk about is how to tell if something is dependent or independent. Okay, so an independent variable is a variable that changes on its own. A really common example of this is time. So time will always go forward on its own, regardless of anything else that's happening. So if time is one of your variables, it's always independent. The dependent variable will change based on the independent variable. So for example, if I say Ramona makes $12 an hour, how much money will she make by the end of the week? Well, there's two things that could affect that. The first variable is how many hours she works, or the time. Okay, that is the first variable. And then the second variable is how much money she's actually going to have at the end of it all. She's actually going to make. Okay, so that's the money variable. Now, usually it's easier to identify the dependent variable first, unless one of them is time, and then you always know it's independent. So I might just right away say, okay, this is going to be my independent variable because it is time. But if you weren't sure about that, you would say, okay, which one of these depends on the other? Well, the amount of money that she makes in a week depends on how many hours she works. The more hours she works, the more money she's going to make. So this amount that she's going to make is dependent on the time. So it's dependent on the other variable. So I could set this up as a table and say time and money. If she works 1 hour, she'll make $12. If she works 2 hours, she'll make 24, etc. Or I could write it as an ordered pair. Again, it's always our independent first and then dependent. So if she works 1 hour, she'll make $12. She works 2 hours, she'll make 24, that kind of thing. Or I could, of course, write it as a graph. Our independent variable always has to go on our x-axis, so we'd have to have time across the x and money on the y. And then I might say after 1 hour, she'd have $12. After 2 hours, she'd have 24, etc. Okay, so those are the three most common ways of representing relations. Just make sure that if possible, you do always identify your independent and dependent variable. Sometimes if they're both words, you might not have one. So if both of your sets of terms are words, don't worry about this too much. But if they're both numbers, like this example here, where you can represent time as a number and you can represent money as a number, then you want to make sure that you're identifying your independent and dependent variables.